Intercepts of linear functions. So we're going to talk about an x-intercept and a y-intercept and how to find them from different forms of lines. So what is an intercept? Well, an x-intercept is where the function crosses the x-axis. This is also called a zero of the function. This is very, very important. We also call x-intercepts zeros. So it may ask you, what is the zero of the function? So for an x-intercept, this is the function, and we need to know where does it cross the x-axis. So here is where it would cross the x-axis. It's a decimal, that's okay. So this would be the x-intercept. I'm going to abbreviate that with int. So we usually do xint. Now, the y value for these is always 0, because if you go to this point, we did not go up or down any. So the y value on here is going to be a 0. So this will be about negative 4.5 comma 0. This is the x-intercept of this particular function. So it's always some number and then a 0. Then we have the y-intercept. Well, that is where the function crosses the y-axis. So for this function here, I want to know, where does this line cross the y-axis? So that would be about here, another decimal. So this is the y-intercept. Again, we're going to abbreviate that with int. There's no special name for this one. So a 0 only talks about the x-axis. It talks about the x-intercept. For a y-intercept, it's just called a y-intercept. For this one, the x value is always 0. And that comes from, we didn't move left or right at all to find this coordinate. So this coordinate would be 0, comma, we'll say about 1.2. This means we did not move over left or right any, and we went up 1.2. So this one's always 0 and then a number. So they're kind of backwards. So the y-intercept has a number on the y portion of the point. Now, this is true for any function, not just lines. This is for anything. We're just concentrating on lines. Whenever a graph crosses the x-axis, it's called the x-intercept. And when it crosses the y-axis, it's called a y-intercept. So any function, this is true. Let's talk about how to determine an intercept from a graph. So to find an x-intercept, well, find where the function crosses the x-axis. So for example 1, my x-intercepts, here's the x-axis. Here's where the graph crosses the x-axis. So the x-intercept would be negative 3, comma 0. And make sure you're writing it in a point. Don't just give me negative 3, because that negative 3 could be negative 3 or it could be down here. We don't know. When you write it in a coordinate, I know exactly which negative 3 you're talking about. So make sure we write these in points. And then for the y-intercept, we want to know, where does the graph cross the y-axis, which is up here at a 6, but more specifically at 0, 6. Let's look at example 2. We have a vertical line. So for the x-intercept, again, I want to know, where does the line cross the x-axis? So that would be here. So 1, 2, 3 at negative 3, comma 0 again. Now for the y-intercept, here's the y-axis and here's the line. Those two never cross each other. There is not a y-intercept for this one, and that's okay. This vertical line will never touch this y-axis here, so there is no y-intercept. Now let's look at number 3, a horizontal line. So the x-intercept, I want to know, where does this line cross the x-axis? Well, it's a horizontal line that's not currently on the x-axis anywhere. It's never going to magically appear there. So there is no x-intercept for this one. And the y-intercept, well, that's right here. There's the y-intercept, because that's where it crosses the y-axis at 0, comma negative 1. Now you try the next 3, 4, 5, and 6. See if you can find the x-intercept and the y-intercept. You should have had for examples 4, 5, and 6. Please ignore the slope line. We'll talk more about that in a couple days. Now what about tables? So to find an x-intercept from a table, well, again, we have to remember that the y value is 0 for an x-intercept. Now you may have to continue the pattern to find this value. So let's look at number 7. I need the y value equal to 0 for the x-intercept. This is y equals 0. So scan the y column. Here's where y is 0. This must be the x-intercept at 2, comma 0. Now for a y-intercept, we want to know where the x value is 0. It's kind of backwards. So we're going to scan the x this time. Here's where x is 0, so this must be the y-intercept. 0, -4. Now for number 8, we're going to use those same rules. So I want to find an x-intercept, so I want to see where y is 0, but I don't see a 0 for y. So let's skip that one. Let's go to the y-intercept. So I need where the x is 0. So x is 0 is here, 0, 9. That's my y-intercept. So for the x-intercept, we're going to have to get a little crafty. I need to find where my y value would equal to 0. And in this case, it's got to be up here somewhere because my y values are adding 3 down the table every time. So in order to hit a y value of 0, I'm going to have to work backwards. So if I take 3 and do the same pattern but backwards, 3 minus 3, I get my 0 that I need. So this tells me I'm on the right track. I need to do the same thing on the x's. So the current pattern on the x's is adding 1 every time you move down the table. So if I need to work backwards, I'm going to use the same pattern, but the opposite operation. So instead of adding 1, I'm going to subtract 1. So -2 minus 1 makes -3. And here is that x-intercept. So sometimes you may have to continue the table forward or backwards to find the intercept that you need. Let's look at 9. I've got -14, 3, -12, 6, and on. And if I want to find the x-intercept, I need a y value of 0. But if I scan my y column, there are no zeros here. So let's see if I can find the y-intercept. So for a y-intercept, x is going to be 0. And again, there is no 0 on the x column. So we're going to have to get crafty. So let's see my pattern. So from 3 to 6, I'm adding 3, adding 3, adding 3. So there's the pattern on the y's. On the x's, I'm adding 2 every time. -10 to 8 is adding 2. And so now let's see. I need a y value of 0 for an x-intercept. Well, that's going to be up here because 0 is smaller than 3. So I'm going to work backwards on my table. I'm going to subtract 3 from the y's, and look, I get my 0. Then I have to subtract 2 from 14 to get -16. And this created my x-intercept at -16, 0. So I found it. It's just not on the table currently. Now for the y-intercept, I need an x value of 0, which falls down the table. It's going to come after -6 on the x. So we're going to keep going. So -6 plus 2 makes -4. And I'm going to continue over here, x, y. Then -4 plus 2 makes -2. Add 2 again, I get 0. So I have to do it a few times on this side. So 15 plus 3 makes 18. Add 3 again, 21. Add 3 again, we get 24. So here is my y-intercept. So this one took a little bit more work. It wasn't just a nice quick go one back or one forwards. I had to go forward a couple times. Try 10 and 11 on your own. See if you can find the x and y intercepts for those. That's what you should have had for your solutions. -6, 0, and 0, 6. And then 11, -8, 0, and 0, 8. Now let's talk about equations. So this is the final one. So for an equation, we also have to remember what is equal to 0 for each intercept. So for an x-intercept, we're going to substitute y equals 0 and then solve. And then when we write our point, we're going to have the x value, comma 0. So let's try that for example 12. So I'm going to find the x-intercept first. So that means I'm plugging in y equals 0. So we're going to have 0 equals -3/2x plus 5. And we're going to solve this for x. So we'll subtract 5 from both sides. So we get -5 equals -3/2x. So to get rid of that -3/2, we're going to have to multiply by -2/3. Flip it over. So the 2/3 and the 3/2 are gone, so we get x equals, remember this is over 1, so -2 times 5 is 10, 3 times 1 makes 3, and I can't do anything with 10/3. So the x-intercept is 10/3, comma 0. There's half of what I need. Now for a y-intercept, we have to remember that the x value is 0, and we're going to solve it for y, and then write it in the point of 0, comma, whatever y is. So same example, but now we're plugging a 0 in a different place. So now for the y-intercept, we know that x is 0. So we have y equals negative 3 over 2 times 0 plus 5. Now in this case, we're not actually solving because y is already by itself. We're just going to simplify this side. So negative 3 over half times 0 makes 0 plus 5, and 0 plus 5 is 5. So for the y-intercept, we have 0, 5. And here are the two intercepts for our example 12. Let's do it together one more time. So for example 13, we're going to find both the x and the y-intercept. So I always just like to start with the x-intercept. So for an x-intercept, we know that y is equal to 0. That's what we know. So we're going to plug a 0 here. So negative 2x plus 3 times 0 equals 48. And then we're solving for x. So 3 times 0 makes 0. And 2x plus 0 is equal to negative 2x. So to get x alone, I have to simply divide by negative 2. So we get x is equal to a negative 24. So our x-intercept is negative 24, 0. And then let's get the y-intercept. So for the y-intercept, it's the same basic process, except your x value is equal to 0 this time. So we have negative 2 times 0 plus 3y equals 48. Negative 2 times 0 is 0, plus 3y equals 48. So 0 plus 3y is simply 3y. And then to get y by itself, we divide out the 3. So y is equal to 16. So for our y-intercept, we have 0, 16. I want you to try example 14 on your own. Find the x-intercept and the y-intercept. Here's what we should have had for the x and the y-intercept. Negative 18, 0, and 0, 24. So remember, x-intercept crosses the x-axis and the y value is 0. And a y-intercept crosses the y-axis and the x value is 0.